Oh. Am I audible now?
Yeah, ma'am, it's better.
Fine. So I have few questions. Those questions we are going to solve today. Give me a while. I'll write the question on a board. You see, and you have to write it in your notebook and try to solve. I'll give you the idea about it. Okay. Okay.
Yes,
Students.
ma'am.
Only one student is there. Dhananjay, what happened? Okay, wait a minute. Instead of writing, I'll share the questions with you. Okay, I don't want to waste your time. Give me a minute. Instead of the whiteboard, I'll share content with you directly. Yeah. I hope screen is visible to you.
Yes, ma'am, it is.
Okay, fine. So write for the first question. Yeah. See what it is. Yeah. Write down this question. नहीं पढ़ा मैंने. Write down the question. This question. The radius of length 3 plus, atomic number is 57, is 1.06 angstrom. Which one of the following given values will be closest to the radius of lutetium 3 plus? And the atomic number for the lutetium is given, that is 71. And the options are there in front of you. What logic you are going to give for this question? Any one of you? Yes?
Ma'am, that lutetium, it's an ion, right, ma'am?
Sorry, I'm not getting you.
It
Lutetium.
is an ion. It is an
Both
ion.
both are ion. Both are ions. See, lanthanide with
Oh,
+3
yeah, that
charge.
is also.
Lutetium is also +3 charge. Correct?
Yes, ma'am.
Yeah. And their atomic numbers are given. For the lanthanide, it would be 57 lanthanum. And for the lutetium, it is 71. So these are the atomic number. So obviously, atomic radius must be related to with what? Radius, correct? Yes or no?
Yes, ma'am. Yes.
Yeah. So what should be the relation in between? This relation you have to like consider over here. See what it is. R radius is inversely proportional to the atomic number Z. Fine. Yeah. Means if suppose for the
Yes, ma'am.
lanthanum, consider the radius as R1, then the lutetium radius would be R2. Correct? And if I take the ratio, what I'll get? Yeah. R1 is directly proportional to 1 upon Z1, means like inversely proportional to Z1, and R2 is inversely proportional to Z2. Correct?
Yes, ma'am.
Yeah. So you have to take the ratio of these two. What you will get? R1 upon R2 is equal to, as it is inversely proportional, you will get the reverse ratio, that is Z2 upon Z1. Correct?
Yes, ma'am.
Because they are inversely proportional. Fine. So you have a
Ma'am,
radius.
because it is inversely proportional, ma'am, the radius
Reverse.
of
Yes.
it
Got
should
it?
be
Because
lesser than
R1
the
upon
radius
R2 is
of
equal to what?
lanthanum.
1 upon Z1 into Z2 upon 1, because it become inverting though. And if I write it correctly, I'll get R1 upon R2 is equal to Z2 upon Z1, because Z1 ones are Z2 ones are Z2 and Z1 ones are Z1. Correct? So this ratio you will get. Because it is inversely proportional. If it would be directly proportional, then you have to write it Z1 upon Z2 directly. Got
Yeah,
it?
yeah, yes, ma'am.
Fine. It's a simple mathematic logic. Now what you're going to do, you have to put the values, what they ask you to calculate. The radius of lanthanum is given. That is what means R1, 1.06. This is the value for R1. R2 you have to find, right? Z1 and Z2 is given to you. 57 is nothing but a Z1 and 71 is nothing but Z2. Put the value and calculate the terms. Go for it immediately. Can you do that? Okay, option C. Dhananjay said the answer because it is decreases from lanthanum to lutetium, it will be less than lanthanum. Okay, it's a great logic. Let's see. Put the values and calculate the term. What you will get? Yeah. In this, you're going to put the values. You will get what? R1 is equal to what? 1.06 upon R2, which is equal to Z1 is equal to 57. And sorry, I'm sorry. Z2 should be there for Z2 is equal to 71, correct?
7.
And
Ma'am,
Z1 is
am I
equal to
audible?
50. Yeah, you are audible, beta.
Ma'am, actually, I think my voice is reaching to you late, ma'am. So, like, what I'm telling you're not able to hear it properly.
No, you're audible properly. No issues.
Okay, okay,
Any
okay.
problem?
Yes.
Any problem over here? Whatever I
No,
have
ma'am, no
explained
problem.
right, we have just put the values. Now go for the cross multiplication. You'll get R2 multiplied with the 71, then 1.06 multiplied with the 57, and R2 is equal to what you will get 1.06 into 57 upon 71. Do this calculation and let me know the value.
I'm getting it somewhere nearby 0.79, ma'am.
0.79.
79.
Okay. Yeah. Actually, Dhananjay gave me the correct answer and he said the answer is 0.85. Okay. The logic is correct. Yes, we know that like when lanthanum to lutetium, when we move, atomic radius goes on decreases. But then apart from that, this ratio you need to means this logic you need to keep it in your mind. Radius is inversely proportional to the atomic number. Means as atomic number is increases, what happened? Radius would be decreases. Fine. And by the
Ma'am, are
calculation,
both of them from the same series, ma'am, Lanthanide series?
sorry,
Are both of them from the Lanthanide series?
yes, you also got the same answer,
Yeah, yes, ma'am.
0.85. Yeah, means both way by the calculation and by the logic, you will get the same answer. And your option C is the correct, or third option is the correct option. Okay, write down the answer and write down the whatever explanation I gave that to in your notebook. I'm gonna clear the things. Is it okay? Go for the second. Second thing you write down, second question.
Ma'am, I'm not able to see the second one. Oh yeah, now good.
Yeah, that's what I'm scrolling down. Are you able to see now?
Yeah, yes, ma'am.
Yeah, please write down. Increasing order of the ionic radii of the given isoelectronic spaces is. So these are the options which are given to you and you have to find it out. Increasing order of the ionic radii and all spaces are isoelectronic. First of all, let me know the meaning of isoelectronic. What do you mean by isoelectronic? Hmm?
Ma'am, whatever ions are given, ma'am, they have the same number of electrons,
These
but
all
different
ions.
structures.
Okay. So they asked you to which one is increasing order of ionic radii. Increasing order of ionic radii. Understanding. Increasing means what? The first one has a less atomic radius. Ionic radius. It won't be
Yes.
atomic. It would be ionic radius. Okay. And last one has a large or big at ionic radius. First of all, what you have to keep it in your mind for it must be started with the cation. We know this cation has a less atomic radius as compared to your neutral atom, and neutral atom has a less atomic ionic radius or ionic radius as compared to anion. Correct? And even the size of atom is also matters. Correct?
Yes.
Yes or no? So if we go for the atomic number, this is 20, this is 19. Correct? Here this would be 17. And this would be sulfur. How much? Sulfur is 32. Correct? Yes or no? Come on, speak up.
Sulfur?
Yeah, fourth. Dhananjay, why fourth option? Yeah, see here. Calcium has an atomic number 20. It's removed 2 electron from its outermost shell. It has 2 plus charge on its head. Right? Then we go for the potassium. It has only 1 plus charge. Then we go to the chlorine. It has only 1 minus charge. And for the sulfur, it is minus 2 charge. This is our basic rule. Cation has a less atomic radius as compared to neutral, and anion has a more as compared to neutral. Correct? So what you come to know over here?
Yes.
Yes. Now see, positive charge, due to the more positive charge on the cation, whatever electrons are present in the calcium Ca2 plus get attracted towards the nucleus, and it will be contraction into the atomic radius. It get more attracted towards the nucleus. Fine. Then if we move to the potassium, number of electrons would be same, but then charge onto the charge on it, it will be what? Plus 1. What is the charge? Plus 1, isn't it? So in this case, what happened? In this case, what happened? Electron get attracted towards the nucleus, but then positive charge only would be 1 as compared to previous one. And hence it will be get attracted toward nucleus, but less as compared to previous one. And hence atomic radius or the ionic radius would be bigger as compared to calcium 2 plus. When we go to the chlorine, in this electron is added into the valence shell, means outermost shell, right? And addition of electron would be increase the shielding effect. It goes farther from to the nuclear charge, and hence its atomic radius would be increases as compared to your positive ion. And here, instead of 1, how many electrons are added into the outermost shell? 2 electrons been added to the outermost shell. So more shielding effect, more distances increases, and atomic radius increases. But then if you see the previous one, here, you can see plus 1 over here, minus 2 over here, plus 2 over here means there is no any sort of sequence of increasing. Here you can see fluorine Cl minus, calcium 2 plus. This is also not increasing sequence. You can see this is a completely reverse thing which is given at the last option. And hence your option 4 is the correct answer. Right? What you have to keep it in your mind, this one, which I have explained you yesterday. Cation has a least atomic, ionic radius as compared to neutral, and anion has a more atomic ionic radius as compared to neutral. Got it? Hello. Students, am I
Yes, ma'am.
audible to you? Understood or not? Please write down this.
Yeah, ma'am, done, ma'am.
Fine. Shall I erase it? Sorry. Write down the third problem. The first ionization potential of sodium is 5.1 electron volt, and value of electron gain enthalpy of Na will be. What will be the value for electron gain enthalpy? Ionization potential means removal of electron require how much energy? 5.1 electron volt. For the addition of electron, how much enthalpy it will be required? And options are there in front of you. How are you going to solve this? Come on, tell me. Hello, students. Am I audible to you?
I didn't get it, ma'am.
You didn't get it. Fine. So they have given you what? The first ionization potential of sodium. Sodium, it has atomic number 11. Its electronic configuration 2, 8, 1. So first ionization potential means what? The amount of energy required to remove one electron from its outermost shell. How much energy would be required according to them? 5.1 electron volts. Correct? Yes or no? So what they said, the value of electron gain enthalpy for the sodium will be, means once you have removed this electron, so how much energy you will require? It becomes Na plus 1 when you remove one electron, and its electronic configuration will become what? 2, 8. Right? If you have to add one electron in this, how much energy you will require? And that energy is called as what? Electron gain enthalpy. Electron gain enthalpy of sodium, and it is denoted with delta H. It is always equal to the ionization potential of sodium, but with opposite sign. So that will be what? Minus 5.1 electron volt. Is given your option? Yes, very good, Dhananjay. Understood? Hello? Shreyasi, understood, beta? Jaswant is not
Yeah, ma'am.
communicating.
Yes, ma'am.
Jaswant is not communicating at all. Jaswant, are you understanding? Yes, no, say something. Come on, write down fast and then we'll move to the next problem. Shall I erase it?
Yeah, ma'am. You can, ma'am, now.
Fine. Now we'll move to the next problem. That is, according to the periodic law of elements, the variation in properties of element is related to their nuclear mass, atomic number, nuclear neutron proton number ratios, or atomic masses. According to periodic law of elements, the variation in a properties of element is related to their nuclear mass, atomic numbers, nuclear proton number ratios, or atomic masses. This is so basic. Yeah.
Atomic mass.
Are you sure?
Periodic law
Hmm?
of elements. Is it atomic numbers?
Okay. Tell me first of all. Yes, Dhananjay, it's atomic number. Yes, Shreyasi, it's atomic number. Because when Mendeleev gave us periodic table, he arranged all the element according to atomic masses, increasing to their
Yeah.
atomic masses. But then Moseley, in a modern periodic table, he revised its periodic law and he said what? All the elements have the fundamental basic properties with respect to its atomic numbers instead of
Number.
atomic mass, isn't it? So instead of atomic masses, he replaced the word atomic number. So atomic number is more basic and fundamental property for the elements. And hence your option 2 is correct. Clear? Fine. Go for the next. I'll scroll it down. Which one of the following is amphoteric oxide? It's very easy. You have already learned it in a grade 10 as well.
ZNO.
Yes, very good. Why it is so? Fine.
Zinc is an amphoteric oxide.
But then why?
And
Zinc oxide.
acha.
Zinc oxide is
Because
an
it acts as a base and
as well
as
as
well as a
acid.
acid.
When zinc oxide react with hydrochloric acid, it will form zinc chloride ZnCl2 plus H2, correct? Yes or no?
Yes,
We
ma'am.
need to balance it, right? And when
H2O, na,
zinc
ma'am.
oxide react with sodium hydroxide, it will give you sodium zincate, both acid and base.
Yes, ma'am.
Yes, it will
Sodium
give you
zincate.
sodium zincate. How are you going to form the sodium zincate? What was the formula? Na
Na
plus
Na2O2.
Zn. Na2Zn. Why? It should be balanced with oxygen as well because it is plus
Yes,
2
ma'am.
plus 2 and this minus 2 become minus 4. So plus 2 plus 2 plus 4 and minus 4, they nullify each other. So formula would be
That is the
Na2.
oxidation, right, ma'am?
Yes. Plus what? Plus what?
Hydrogen.
Hydrogen.
Hydrogen. Yes, ma'am.
Check this. Need to multiply it by 2. Clear? H2O, I guess. Check it once for this balance equation later. Okay. Fine. But then answer would be zinc
Ma'am, but
oxide.
still,
Fine.
ma'am, because it is an amphoteric oxide, it should give hydrogen gas on liberation.
Yes. In this case, oxide, those are react. One more is there, aluminum oxide and the zinc oxide. When these two react with the base as well as acid, it will release the hydrogen and form the salt. Right? Yes or no? Hello? Students, where you disappear meanwhile?
Yeah, yes, ma'am. Yes, ma'am.
Fine. Now, sixth question. In order to increase size of atomic radii, among the elements, oxygen, sulfur, selenium, and arsenic is increasing size of atomic radii among the elements oxygen, sulfur, selenium, and arsenic. What would be the answer? I'll just scroll it down. Maybe if option would be when the correct option would be down, then you wouldn't be seen. Now check. Dhananjay is so fast, right? Dhananjay, how come? Very good. Come on, tell me what would be the trend? Increasing atomic radii means from less atomic radii, you have to go for the high atomic radii, right? So we know that in a
Yes, ma'am.
first period, second period oxygen is there. Correct? I think sulfur would be the in next period. In same period, it won't be there. So obviously sulfur is bigger than that because atomic number you should be aware of, right?
Yeah, yes, ma'am. Sulfur
Yeah.
is 12.
And then selenium and arsenic's atomic number you should be aware, then only you are able to do that. What it is? Check it once. Atomic number for selenium and arsenic. So these two are really very proper, like oxygen, right? First one would be the oxygen, which has less atomic radii as compared to sulfur. Now there is a question in between selenium and the arsenic. So two options are there. Here it is, and here it is. Now among these two only would be the answer. These two would be rejected. Correct? Now check. Arsenic has the more atomic number or selenium has the more atomic number. Check it once. Periodic table everyone has with you, I guess. MCQs are easier. Okay. Fine. Good. What it will be? Arsenic would be here. And then selenium. Check the atomic number once, you'll get the idea. Keep periodic table in front of you. So your option second is correct. And this would be wrong. But this one also would be wrong. I'm sorry. It's my bad. It's my bad. Here, selenium would come first and then the arsenic. So your option fourth is correct and option second is wrong. Extremely sorry for this. Okay. Please, Ms. Lake, correct your answer. This won't be a proper answer. Your proper answer would be oxygen. It has a less atomic radius than that of the sulfur, which has a less than that of the selenium and the less than that of the arsen. Fine. While checking the answer, no, not option 2, beta. Option 4 is the correct one. Dhananjay. Now, Shreyasi got disconnected, I guess. And go for the next. Yeah. See her. I don't feel like that you have a maths class today. Till 5 o'clock, I'll explain. Okay. And after that, we'll see. If class would be there, you will get the notification regarding. Okay. Now see the next, beryllium and aluminium. Exhibit many properties which are similar, but the two elements differ in exhibiting maximum covalency in a compound, exhibiting amphoteric nature in their oxides, forming a covalent halides, and forming a polymeric hydrides. What sort of properties are exhibit differently by beryllium and aluminium? Think over it once. Come on. This would be the question 7. And to see what is given to you. Beryllium, if we see, it belongs to the second period. Have you seen it? Do you have periodic table with you? Okay, fine. No idea. Okay. See, beryllium belongs to the second period and aluminum is belong to the third period. Correct? Yes or no? beryllium, and aluminium. This is belong to second period. This is belong to third period. Okay. Then after that, what you'll come to know about it? They have a different electronic configuration. That electronic configuration is also not same. If we see beryllium, what is the atomic number for beryllium? 4, right? And aluminium, it would be what? 13. Electronic configuration would be 2, 2. Here 2, 8, 3. Correct? Yes or no? Yeah. Their covalencies are different. Covalency, here it will be 2 and here it will be what? 3. So beryllium and aluminium have a diagonal relationship. They possess similar properties, but they differ in the existing maximum covalency in a compound. Right? Yes or no? So they differ in maximum covalency in compound. Your option first one is the correct. Got it? How to find it? Beryllium in the second period, aluminum is in third period. Its atomic number is 4. Beryllium's atomic number is 4. Aluminum's atomic number is 13. If you write its electronic configuration, it will be 2, 2 for beryllium, 2, 8, 3 for the aluminium. What you will come to know? Valency of beryllium would be 2 and valency of aluminum would be 3. And hence they have a differ in their covalency, exhibiting maximum covalency. Maximum covalency in a compound, it's a different with respect to beryllium and aluminium. Fine. They have a diagonal relationship and hence they shows more similarities in their properties. Fine. That too you have to keep it in your mind. Why they show similarities in their compound or in their properties. If suppose somebody asks, you should have to write the answer. They have a diagonal relationship in a periodic table. Okay. Go for the next question. At least 10 questions we will solve. Which is the correct order of second ionization potential of carbon, nitrogen, oxygen, fluorine in the following? Options are there in front of you. Second ionization potential means first ionization potential and second ionization potential means what? First of all, tell me that. All of we know the number of atoms which has been given over here, that are carbon, nitrogen, oxygen, and fluorine. Its electronic configuration you have to write in S and P orbital frames. All are, I think, P block elements, right? Carbon, nitrogen, oxygen, phosphorus. These all are what? These all are what? P block elements, correct? Yes or no? For carbon, it will be what? 2s2, 2p2. For nitrogen, it is what? For nitrogen, it is what? 2s2, 2p3. For oxygen, it is what? 2s2, 2p4. And for fluorine, it is what? Sorry, 2s2, 2p6, I guess. Not 3. It will be 2p6. And 2s2, 2p5. 9 it would be, no? Fine. Sorry, 2s2, 2p6, not 2p6, it would be, I'm sorry. 2p4 and 2s5. 7, 8, 9. Okay, fine. It's due to atomic number because 1s2, 1s2 is missing. I haven't wrote here. 1s2, 1s2, 1s2. See, 1s2, 2s2, 2p2. Correct? Atomic number 6. Here, 1s2, 2s2, 2p3. Here, 8. 1s2, 2s2, 2p4. And here, 9. 1s2, 2s2, 2p5. So this is electronic configuration. Correct? Yeah. Now what you're gonna do here? What has been asked to you? One electron you have to remove in each last valence shell. When you remove one electron, that would be your first, means energy required to remove one electron, that would be the first ionization potential. But then here they have asked you to remove second ionization potential, which is the correct order of second ionization potential of carbon, nitrogen, oxygen, and fluorine. When you remove one electron, what you will get? Yes, 2s2, 2p1 after removing one electron. Here you will get what? 2s2, 2p2. After removing one electron, here you will get 2s2, 2p3. After removing one electron, here you will get 2s2, 2p4. Correct? Yes? This is your first ionization potential. This thing you will get after removing one electron. Fine. Now what you will get after removing second electron? Yeah? If you see first one, here, 2s2, 2p1. It will occupy ideal gas configuration and hence it will be easily give away the second electron because p orbital has only one electron in it, right? So it will be easily lose the second electron, right? So it require less ionization, less second ionization potential. Right? What about this? It has to lose two electrons. Then only it will gain the ideal gas configuration. And hence it will require a more ionization potential as compared to the previous one. The similar for the next one, as I guess, right? It will have three electrons in a p subshell, which make it very unstable. So it will have a high ionization potential, right? Three. Okay, so it is half filled. 1, 2, 3, 1, 2, 3. It's a half filled p orbital. It become unstable and it require a more ionization potential. Ionization potential. And the lastly, what? We have a fluorine. It has a 4 electron in it, right? And as it has a 4 electron, it will occupy the stable half-filled configuration. Sorry, the half-filled configuration. And so that's why the energy would be, which one has more? Oxygen has more. As I said you. Then next one would be for the fluorine. And after fluorine, they would be for nitrogen. And then they would be for the carbon, because carbon require least. When it's give your second electron, it become a inert, and hence it require very less ionization potential. Nitrogen has to lose 2 electrons. It require more as compared to carbon, right? Oxygen is highly unstable, and hence it require what? More energy, high ionization potential. So it will be jump after the fluorine, and fluorine require less as compared to oxygen, right? So this would be the correct order. So your oxygen, fluorine, nitrogen, and carbon. First option is the correct one. Got it? Fine. Okay. So it's 5 o'clock, students. I think we have to stop. If you want, I'll share these questions with you. Only questions I will share with you. You have to try to find out the answer. Around 17 to 18 questions are there with you. Fine. Shall I end the class? Hello.
Yes, ma'am. Hello.
Yeah. Tomorrow, same time we are meeting. Fine.
Okay.
I'll bring up some more difficult problem which we can sit and solve.
Ma'am,
Take care, bye.
tomorrow's class is 2:20 or 2:45?
Tomorrow would be Thursday, right?
Yes.
So I think Wednesday and Thursday it would be 2:45, and
Okay.
rest all day would be 3:45. Okay.
Yeah. Okay.
Yeah. Timetable is already shared with you guys.
Yes, ma'am.